Welcome back to the deep dive. Today, we're going deep on something that you might not have heard much about.
Yeah.
Bacteriophages, or phages for short.
Phages, yeah.
Tiny viruses that infect and kill bacteria, and they're starting to get a lot of attention as a potential new weapon in the fight against these antibiotic-resistant superbugs.
Right. It's a really fascinating area of research, and it goes back to this ancient battle
Yeah.
between viruses and bacteria.
You send over a bunch of articles and research for this deep dive.
I did.
And I gotta say, some of this is pretty mind-blowing. Like, did you know that there are more phages on Earth than all other organisms combined?
It's true.
That means there are billions of them probably hanging out with us right now.
Yeah. It puts things in perspective, doesn't it?
Yeah.
We kind of forget about this invisible world that's just teeming with life, or in the case of viruses, not quite alive, but impactful nonetheless.
Yeah, so let's start with the basics.
Sure.
What exactly are phages?
So imagine a virus that looks like a tiny lander.
Okay.
It's got this head that's like a 20-sided container that holds the phage's DNA, and then it's got this tail that injects that DNA into bacteria.
So it's like a microscopic assassin.
Exactly. And each phage is specifically designed to attack only certain types of bacteria, which is really important when we start talking about their potential use in treating infections.
Got it. And how do they actually kill bacteria? What happens once that DNA gets injected?
Well, once the phage DNA is inside, it takes over the bacteria's machinery and forces it to produce more phages.
So the bacteria becomes like a phage factory.
Basically.
That's kind of disturbing. And then what happens? How does the bacteria actually die?
Think of it like this: the bacteria gets so full of all these newly created phages that it basically explodes, releasing a fresh batch of phages to infect even more bacteria.
Okay.
It's remarkably efficient, and that's one of the reasons why they're so effective at killing bacteria.
Okay, I need a minute to process that visual. But you said phages are all around us, right?
Okay.
Are we talking about harmful bacteria? Are there good bacteria in the mix too?
All kinds of bacteria. But remember, phages are very specific, so they only go after certain strains, not all bacteria.
Right.
And the good news is that they don't target human cells, so they're harmless to us.
That's reassuring.
Yeah.
But why is there all this interest in phages now? What makes them so important today?
Well, it comes down to antibiotic resistance.
Mm.
You know, for decades, we've been overusing antibiotics,
Yeah.
and bacteria have evolved to fight back.
Right.
So we're now facing this situation where infections are becoming more difficult to treat because the bacteria are resistant to the antibiotics we have.
The rise of the superbugs, right?
Exactly.
Yeah, it's definitely something we've all heard about. It sounds pretty scary.
It is a serious concern.
Mm.
Some estimates suggest that by 2050, superbugs could be killing more people than cancer.
Wow, that's a sobering thought. So how do phages fit into this? Are they like a potential solution to this superbug crisis?
They could be. Remember how we talked about phages being so specific in the bacteria they target? Well, that means they can kill the bad bacteria without harming the good bacteria in our bodies, which is something that can happen with broad-spectrum antibiotics.
So it's like a sniper rifle versus a grenade launcher.
Exactly. And because phages have been battling bacteria for billions of years, they've evolved to become incredibly efficient killing machines.
Sounds like we've got a lot more to unpack here. This is already getting really interesting.
It is. We're just scratching the surface.
Yeah.
There's a lot more to learn about how they work and how they're being used in therapy and what the future holds for this field.
Well, let's dive into it. So we've established these phages are like little assassins that take out specific bad bacteria.
Right.
But how do we actually use them to treat infections? Is this something that's happening now?
It is. It's called phage therapy. And while it's still experimental in many parts of the world, there have been some remarkable success stories.
Okay.
One that comes to mind is a patient who had a really serious chest infection
Yeah.
caused by bacteria Pseudomonas aeruginosa.
I think I remember reading about this case. He wasn't responding to antibiotics at all, right?
Exactly. Antibiotics weren't working, and the infection was life-threatening. So as a last resort, doctors decided to try phage therapy.
Wow.
They were able to find phages that specifically targeted his strain of bacteria and administered them intravenously.
And what happened?
Within a few weeks, the infection cleared up completely.
Wow.
It was a truly remarkable recovery. And it really highlights the potential of phage therapy, especially in cases where antibiotics fail.
That's incredible. It's amazing to think that something we've always thought of as bad a virus could actually be used to save lives.
Right.
It really challenges our perceptions.
It does, and that's part of what makes this field so exciting. We're learning to see viruses in a new light,
Yeah.
not just as agents of disease, but as potential allies in the fight for our health.
So why isn't phage therapy more common? If it's so effective, what's holding it back?
Well, there are a few challenges.
Okay.
One is that phage therapy is inherently personalized. You need to find the right phage for the specific bacteria causing the infection.
Right.
It's not like an antibiotic where one drug can treat a broad range of infections.
So it's more complex than just popping a pill.
Much more complex.
Okay.
It requires this careful matching of phages to bacteria,
Gotcha.
and that can be a time-consuming process.
Yeah.
Another challenge is that there hasn't been a lot of investment in phage therapy research until recently.
Why not? If it has so much potential.
For one thing, it's a relatively new field compared to traditional antibiotic development.
Okay.
And for a long time, pharmaceutical companies weren't very interested
Yeah.
because phages are naturally occurring,
Right.
which means they can't be patented
Right.
in the same way as synthetic drugs.
Yeah.
So that makes them less commercially attractive.
So it's a business problem as much as a scientific problem.
In a way, yes,
Yeah.
but that's starting to change.
Yeah.
With the rise of antibiotic resistance, there's this growing recognition that we need new solutions.
Right.
And phages are looking increasingly promising. We're seeing more research funding, more clinical trials being conducted, so I'm hopeful that we'll start to see phage therapy becoming more widely available in the years to come.
That's good to hear. It sounds like a really dynamic field with a lot of potential.
Absolutely.
Yeah.
And what's really fascinating is that as we learn more about phages,
Yeah.
we're also learning more about this complex interplay
Okay.
between bacteria and viruses in our bodies and in the environment.
That makes sense. We've talked about downsides of antibiotics, but what about phage therapy? Are there any risks or concerns
Yeah.
associated with using phages to treat infections?
There are always potential risks with any medical treatment.
Of course.
With phage therapy, one concern is that the body might mount an immune response to the phages,
Okay.
which could reduce their effectiveness.
Oh.
But researchers are working on ways to engineer phages to minimize this risk.
So what about the bacteria themselves? Could they become resistant to phages in the same way they become resistant to antibiotics?
It's definitely a possibility. Bacteria are incredibly adaptable. But here's the thing. Phages are constantly evolving too.
Oh.
It's this constant arms race that's been going on for billions of years.
So it's like a battle that never ends.
Exactly. And because phages evolve so quickly, they can often stay one step ahead of the bacteria.
Wow.
They're able to adapt and develop new ways to overcome these bacterial resistance mechanisms.
That's really reassuring. It makes phages seem even more powerful knowing that they're constantly adapting and evolving alongside the bacteria.
It really highlights the elegance of nature's solutions, doesn't it?
It does. And it makes me even more curious about what the future holds for phage therapy. So we've covered what phages are, how they work, and why they're so promising in the fight against these superbugs. What does this all mean for the future of medicine?
It's an exciting time to be in this field.
Mm-hmm.
We're potentially on the cusp of a major shift in how we approach bacterial infections. The era of relying solely on antibiotics is coming to an end,
Mm-hmm.
and phage therapy could be a key part of what comes next.
It's definitely a paradigm shift to think about using viruses to heal instead of to harm. But what you've described makes it seem like they could really be a game changer.
They have the potential to be, especially as antibiotic resistance continues to rise. Imagine a world where we can target the specific bacteria that are causing infections without harming the beneficial bacteria in our gut or elsewhere in our bodies.
That sounds like a much more balanced approach than what we have with antibiotics, which often feel like a sledgehammer when what you really need is a scalpel.
That's a great analogy.
Yeah.
And because phages are constantly evolving, they're less likely to lead to those same resistance problems that we see with antibiotics.
That's one of the things that struck me as so remarkable about phages. They're not just a static solution. They're dynamic, always adapting and evolving.
It's a reminder that nature often has solutions to the problems that we face. We just have to be open to exploring them.
We started this deep dive talking about how many phages are all around us, and I have to admit it was a little creepy at first.
Oh!
But now knowing what I know, it's actually kind of reassuring.
I understand what you mean. It is a shift in perspective. Instead of seeing viruses solely as threats, we can start to appreciate their complexity and their potential to be beneficial.
This whole conversation has definitely given me a new appreciation for this invisible world around us
Absolutely.
and the intricate ways that all these different organisms interact.
Yeah, me too. It makes you wonder what other discoveries are waiting to be made out there.
Exactly. Who knows what other secrets nature holds that could help us solve some of these big challenges facing humanity.
Well, one thing we do know is that phages are incredibly diverse. There are likely millions, if not billions, of different types of phages out there, each with its own unique set of characteristics and capabilities.
That opens up a world of possibilities. If phages are so good at targeting specific bacteria, could they also be used to manipulate the microbiome in beneficial ways?
That's a really interesting question, and it is something that researchers are starting to explore. The microbiome, the community of trillions of bacteria that live in our gut and elsewhere in our bodies, plays a crucial role in our health.
So theoretically, you could use phages to get rid of harmful bacteria in the gut or even introduce beneficial bacteria.
Potentially,
Yes.
but it's a very complex ecosystem,
Yeah.
and we're only just beginning to understand the intricate ways that all these different microbes interact with each other and with our bodies.
It sounds like there's still so much to learn, but the possibilities are incredibly exciting.
I agree. Phage research is a rapidly evolving field with the potential to revolutionize how we treat bacterial infections and perhaps even how we manage our overall health.
It's definitely a journey worth following. And who knows, maybe one day we'll be looking back and wondering how we ever lived without phage therapy.
It's certainly a possibility.
Well, I think we've covered a lot of ground today. We've gone from thinking of viruses as the enemy to seeing them as potential allies in the fight for our health. It's been a fascinating deep dive into the world of phages, and I, for one, am eager to see what the future holds for this promising field.
Me too.
Yeah.
It's been a pleasure discussing this with you.
And to all of you listening out there, thanks for joining us on this deep dive. We'll be back soon with another fascinating topic.